During the last 10 years, helicopters flown by the U.S. Navy and Marines suffered approximately 618 flight mishaps. Unfortunately, past efforts to develop in-flight ejection systems for helicopters similar to those used in fighter or attack aircraft have not been acceptable to the helicopter community. Helicopter pilots, air crewmen, and passengers must remain with the helicopter until it impacts the ground. Accordingly, the U.S. Army, Navy, Marines, and Air Force have made tremendous advancements in the protection of helicopter occupants by improving aircraft crashworthiness. It's been estimated that 80% or more of all helicopter mishaps are survivable if proper equipment is provided. In fact, all those mishaps just shown here were survivable. The Naval Air Development Center in Warminster, Pennsylvania, conducted dynamic tests of older generation troop seats in standardized representations of helicopter impacts. The tests, which were conducted at the center's horizontal accelerator facility, would allow direct comparison between the older generation troop seats and the current troop seat specification. Additionally, it was hoped that areas of improvement could be identified for the older troop seats. The H3 three-man seat and the H1 two-man seat selected for testing were representative of all helicopter seats currently in use in their new condition. The seats were oriented to simulate the vertical, longitudinal, and lateral forces experienced by helicopters in survivable crashes. As shown in this model, helicopters crash in an almost horizontal attitude with predominantly vertical impact forces. This is the H3 three-man seat installed on the accelerator sled. Notice that the seat fabric and back straps are very tight. This test run for the H3 three-man seat simulates a minor helicopter crash. Note that although the seat structure remains intact, the forwardmost mannequin experiences substantial forward movement and impacts the deck of the helicopter to the side of the seat. This body movement raises questions concerning the effectiveness of the two-point lap belt restraint system, even when the seat structure does not fail. This test simulates an impact with slightly more force than the previous test run. Notice that the seat structure fails dramatically and that all the mannequins experience violent body movement. The mannequins impacted the support cross tubes located directly beneath them. This caused the tube to become detached from the rear load-bearing rod attached to the sidewall of the airframe. Even if the occupants of these seats were not severely injured upon impact, their ability to rapidly egress the aircraft following cessation of the crash pulses is questionable. This is a test of the forward-facing two-man. Because of wide variations in the occupants, type of helicopter, impact directions, and various other factors, an accurate probability of actual injuries is difficult to determine. However, the combination of impact trauma due to seat structural failure and a degradation in the ability to exit the helicopter after impact could significantly decrease the overall survivability of occupants in otherwise survivable mishaps. The testing for both H3 and H1 troop seats suggests that proper maintenance and installation significantly improves the performance of the seats. Specifically, a tight seat fabric and tightly adjusted seat backstraps strengthen the overall seat structure. Additionally, the proper attachment of the locking mechanism in the troop seat leg to a floor stud and square alignment of the seat structure to the aircraft sidewall also contribute to seat performance. As a result, the following recommendations are made. Energy attenuating stroking seats must be correctly matched to the airframe and the orientation in which they'll be used. It's not as simple as buying a seat off the shelf, then installing it. However, crashworthy technology for troop seats has gone from theory to reality and has near-term potential to greatly improve survivability for troops and passengers in all helicopters. In conclusion, the second graph shows the ratio of total energy tolerated by the older generation troop seats compared to new generation requirements prior to seat structural failure.